Okay, first we're going to define a secant, because that was the third part of our trichotomy from yesterday, which is right there. So remember, not very exciting. Tangent, what was a tangent again? Who helped us? Emily, was that you?
Yeah.
What's a tangent?
A line segment, a line, ray, or segment that intersects a circle at exactly 1 point.
Beautiful. Now we get a secant. I already gave you the definition. Notice that the secant there is a line. Okay, now I know it says in the definition a line, ray, or segment, but we're looking at the line component of it, because if we turn it into a segment, well, let me ask you, what do you notice about a secant?
It's kind of like a short.
It's got a chord wrapped up in it, yeah. So if you take a chord and you extend it into a line, all of a sudden you get a secant. Okay, so in essence, it's a line, not in essence, it is a line that hits a circle in exactly 2 points. What if it passes through the center? 3 points?
That would be a diameter.
It'd be a triangle.
No, but. It'd be a diameter with 3 points.
Yeah, I was
I forgot where I was. I don't even know what we were talking about. The triangle came up and it just... Oh, if it passes through the center of the circle, does it hit the circle in 3 points?
No.
Why not? Wow. All right, let's move on.
Okay.
All I got for you today is a bunch of theorems. They're kind of confusing. And a bunch of examples. So here's the first one. Now we're going to start relating angles to arcs, or not start, we're going to continue relating angles to arcs. This looks kind of scary. However, before you write it down, think of it this way. Where's the vertex of the angle? B, correct. Is that vertex at the center of the circle or on the circle? And what do you know about any angle whose vertex is on the circle?
Arc is 2 times.
The arc is twice the angle measure, or the angle measure is half the arc. That's the same scenario here. The only difference that we're doing here is you're used to seeing an inscribed angle where both rays of the angle are inside the circle. I just moved it over a little bit. I took a secant with a tangent instead of 2 secants. So the rule's the same. So you don't even really have to learn this one, because you just ask yourself, where's the vertex? It's on the circle? Okay, then it's half. You with me?
Yeah.
Good. Also, this bears mentioning, what's the relationship between arc BC and that big arc all the way around?
Equals 360.
360, correct, because there's 360 degrees in a circle. Okay, so not very exciting, right? How big's QPS? Rebecca, are you doing yoga or raising your hand?
Stretching.
Stretching.
Yeah.
Okay. That wasn't like crescent moon or
No.
laughing tree or yawning frog or whatever else.
No.
Okay, something like that. Morgan.
Could you go back a slide?
Sure. Sorry, it's the shoes. Okay. How big's angle QPS?
125.
$1.25. Where's the vertex? On the circle, therefore it's half the arc. How big is angle RPS? No,
110.
no.
Oh, I got it.
55, right?
Yeah.
Why?
Because it's half of one. Sorry. It's half of 110, which is 360 minus 250.
Okay, 2 ways to do the problem. One is, he said that if this is 250, then this arc is 110, and it's, since the vertex is at the on the circle, then it's going to be half of the arc. Or, if that's 250, we already determined that that's 125. These two angles form a linear pair. 180 minus 125 gives you that 55 degree measure. All right. Now we put it somewhere completely different. We've got at the center of the circle, we've got on the circle, and now I put it inside the circle. Inside but not at the center. Anywhere in there. So you'll see, before you start writing, don't write this down. There's too much to write here, and it's not going to mean anything to you. Just listen first. Vertex is inside the circle somewhere other than the center. If it's at the center, it's not very exciting. It intercepts two arcs. Okay, so here in the picture, I've got arc AB and arc CD. The thing to remember here, first of all, what's the relationship between angles 1 and 2? They're vertical angles, which makes them congruent. So if I find one, I can find the other, because that's easy. The theorem says this. You take the two arcs, add them up, divide by 2, also known as an average. Take the average of the arcs. Center of the circle, arc equals the angle. On the circle, arc is twice the angle. Inside the circle, average of the arcs. Which one haven't we done yet?
Outside the circle.
Outside the circle. Guess what's coming next? Maybe. Segment's killing me, isn't it? Okay. So don't copy all this gunk down. It's not going to mean anything to you. If the vertex is inside the circle, take the average of the intercepted arcs. We good?
Yep.
Take the average.
If the vertex is inside the circle, take the average of the intercepted arcs. Arc 1 plus arc 2 divided by 2. Arc 1 plus arc 2 times a half. Hmm? What? Okay. You sure? Alright.
Yeah.
Alright. There it is outside. Woohoo! When it's outside, it's going to intercept two arcs. The bigger arc is always farther away. There's no exceptions to that rule. Okay. Biggest arc is farthest away. Therefore, the rule is not this big scary paragraph. Big arc minus little arc divided by 2. Inside plus, outside minus. It's in the bag, right?
Stop.
What's for?
Track.
Track. What's in the bag? All you need are shoes.
No.
No?
I have stuff in it. Why do you want to know?
I'm just wondering. It's a big bag for running track. I mean, I understand if you play baseball because you got like a helmet and glove and a bat and a mitt and a glove
Okay.
and
Okay.
pants and a sweatshirt,
Okay.
gym shoes, spikes.
Bikes.
What?
Put bikes in your bag?
Spikes.
Oh, spikes.
What do you think I said? Pikes?
Bikes.
Bikes.
I don't know.
Why would I use a bike in softball?
I was writing.
Unless I use it to get to the softball game. But then why would I put it in the bag? I just put it in the bike rack.
Yeah, I was nervous.
Here we go. So, question number 1, Will. Where's the vertex?
L.
At this. At the center of the circle, inside the circle, on the circle, outside the circle.
Outside the circle.
Good. And if it's outside the circle, what's the rule?
Big or
If he talks again, right where the head meets the neck, right there, the pressure point, just take your pencil and you want to go upward with it, okay? Just go right up into, so like shoot for the top of his head, and then it'll stop him from talking. Then he'll just go. Sorry, Will.
Can
What's
you
the?
go back, actually? I didn't get to it.
Sorry, Will. What's the rule? Oh, you mean slide wise?
Yeah.
Okay. Wrong way.
Dude,
Well, that was scary, wasn't it?
Sure.
Okay, until Jabberjaw over here opened his yap. We've established that the vertex is outside the circle, correct?
Yeah.
What's the rule?
You take.
You okay? You wanna share?
Sure.
You sure?
It wasn't about you, that's what I should have done.
Sorry, Will. 2 interruptions now. Vertex is outside the circle.
Don't you take the average of the two arcs?
Nope. That's when it's inside. Yeah, go ahead.
The big arc minus the small.
Get ready. Just go ahead, I'm sorry.
The big arc minus the small arc divided by 2.
Good. And how big is the big arc?
180 minus 102. 360 minus 3. Oh, 360. 204. 258. 58. 258.
250? Like it's my fault. You're on your 3rd guess. And now all of a sudden it's my fault. 258. How big's a small arc?
102.
Okay, so 258 minus 102.
156.
Divided by 2.
78.
Okay, we good?
Yes.
Yeah.
So it all starts with identifying where the vertex is, and then obviously you have to know the rules. Good. Notice also in this one you had to figure out how big the blue arc was, and the blue arc is what's left over from the circle after the 102. Let's go in reverse order. Okay. Oh my God. 3 is the easiest one to find. So Ashley, how big is angle 3?
150?
Say again, I'm sorry. Perfect. Why?
That is half of the,
Why?
because it is in that angle on the circle.
Perfect. Couldn't have said it better myself. Everybody heard that?
Nope.
Where's the vertex? It's on the circle, therefore the angle is half the arc. The intercepted arc is 100. 100 divided by 2 is 50. Good. Want to keep going, Ashley? No, you're done? Okay. Grace, how big is angle 2?
50?
Nope.
Hold on.
Okay.
Where am I calculating? Hold on.
Just going right there.
12.5.
Excellent. Why?
Because it's half of 25, which is the arc measure.
Because?
It's on the outside of the circle.
Well, it's on the circle.
On the
Right.
circle.
Okay. So the vertex again for angle 2 is on the circle, so therefore it is half the arc measure. How big is angle 1, Michael?
Outside would be 260 minus 80.
Say again?
Would it be 80?
No. Let's go through the steps. Where's the vertex?
Outside.
Good. What's the rule?
Big arc minus small arc.
And then?
Divide that by 2.
Good. Where's the big arc for this angle? How big is the big arc for this angle?
260.
Nope.
100.
Hundo. How big's the small arc? 25. 100 minus 25 is
75.
divided by 2.
37.5.
Beautiful, 37.5. How else could I have found angle 1? Okay, quiz problem. You forget the rule for when the vertex is outside. You're panicking. You start to get the sweats. The bell's going to ring soon. How do I find angle 1? You really think you can explain this with the sexy voice going on?
Yeah.
All right, this will be fun. Go ahead.
You do the supplementary angle of angle 3,
Yeah.
and then 1
Get all that?
Yeah.
Solve the triangle. Okay, try that one. Notice that T is not the center of the circle.
Dang it.
Improper? Oh, yes, improper,
Yes.
not mixed numerals.
Yeah, you
That's
want it,
bush league.
everything in fractions.
Rebecca, what do you got for X?
I got 1.
1?
Yes.
Can somebody confirm?
Yeah.
Ooh, please tell us how you found X being 1.
So I added up all of the different arc measures to 360 and I saw
Outstanding. Okay, any problems with that?
Yeah.
Now let's get into the fun stuff. How did you find, well, did you find angle of JTL, Rebecca?
yes,
And what did you get?
141.
1, can somebody confirm?
I'm still working on it.
They're still working on it. Tell us how you got 141.
So I averaged out the measures for JL and NH and that's how I got it.
Awesome. Where's the vertex? Inside the circle. The rule when it's inside is the average of the arcs. One intercepted arc is 100 plus 4x. The other intercepted arc is 183 minus 5x. Of course, we know what those values are because she already found x being 1. Add them up, divide by 2, and you get, you said 131? 141. Therefore, how big is angle LTH? 39 degrees. Outstanding. Well done. I don't know if I have the answers on here. Let's see. Nope, I didn't. Oh, this will be fun.
Another one.
Yeah. But it's the last one. Anybody not know how to start it? You be honest. Good. vertex. Everybody, where's the vertex?
Outside.
Outside, what's the rule?
Big
Big
arc.
arc minus small arc.
Divide by 2.
Big arc minus small arc divided by 2. How big is the big arc?
4x plus 5.
How big is the small arc?
50.
50. Divided by 2 has to equal the measure of the angle. How big's the angle? X plus 2.5. So we get something like this. So then we got 4x plus 5 minus 50 divided by 2 has to equal the measure of the angle, x plus 2.5. Make sense? Easiest way to solve that?
Multiply by 2.
Yeah, multiply both sides by 2. 4x minus 45 is equal to 2x plus 50.
50.
5.
Oh, sorry, 5.0.
Why are you laughing?
2x is equal to 50. X is equal, did I do that right? 25?
Yep.
Yeah, there we go. Then you can plug that in and find the angle measure. Depending on what, this one just asks you for x, but it might ask you for measure of the angle. It might ask you for the measure of the bigger arc. Who knows? It might even get a little kooky and ask you for the measure of that arc. How would you find that?
Solve the angle and then subtract it from 360.
Yep. Use the idea that the angle is made up of